we have discussed some of the general terms related to lenses, is it not? So today we shall just see how the light will undergo refraction through a lens. Here I have a biconvex and a biconcave lens, and these two lenses are equiconvex and equiconcave lens. Now equiconvex and equiconcave. What do you mean by that? So by this we mean the radius of curvature of both the surfaces will be same. Now in the previous session I have told you what is radius of curvature. Radius of curvature is the radius of the imagined sphere of which the refracting surfaces or curved surfaces are a part. So here both the curved surfaces are a part of the imagined spheres and their radii of curvature will be same. So the radius of curvature of the first surface will be equal to the radius of curvature of the second surface. So these are the two surfaces, is it not, for lenses, and their radii of curvature will be same, and hence we call them as equiconvex and equiconcave lens. Now let us consider a light ray incident on a convex lens. Here I have drawn a convex lens. So this is the principal axis of the lens, is it not? This is also principal axis of the lens, and I have shown the optic center also. Now let us consider a light ray incident on the lens. Now here you can observe that the light ray is incident on the first refracting surface of the lens. So this is the air medium and lens is made of glass. The light ray is travelling from air to glass, is it not? So when the light ray is travelling from air to glass, how does the refracted ray bend? The refracted ray bends towards the normal. It bends towards the normal. So this part I shall consider it as a straight surface. This part I shall consider it as a parallel surface. Okay, here for this surface I shall draw a normal. Right? I shall draw a normal. Okay. No, so if I draw a normal, then how does the light ray bend? The light ray bends towards the normal. Like this, the light ray will bend inside the lens. Now again, after the light travels through the convex lens, again it is incident on the second refracting surface. Now the light ray is traveling from glass to air, that is from denser to rarer medium. Again here you should draw normal. Okay. At this surface draw normal, and when the light ray travels from denser to rarer medium, how does it bend? It bends away from the normal. Right? It bends away from the normal. So this is the exact refraction of light that takes place when it passes through a lens. Now how many times the light is undergoing a refraction? The light is undergoing a refraction 2 times. Once from air to glass and second time from glass to air. Now you can see that the light ray, it will move away from the normal. It bends away from the normal and travels in the air. Like any other ray you can consider, which is incident on the convex lens. Like if you consider a ray here also, then also here you should draw the normal, right? And how does it bend? Rarer to denser, it bends towards the normal, is it not? And again here, the light ray is traveling from denser to rarer. Here again you draw the normal, it bends away from the normal. So previous session I have told you a convex lens is a converging lens. So if you take any number of rays, all the rays after refraction through the lens, they will converge at a point, and hence it is called a converging lens. Now the same phenomenon, the same process takes place, phenomenon takes place even in case of concave lens also. See here, a light ray is incident on a concave lens. Okay, it is incident on a concave lens. How does it undergo refraction? So here you draw a normal, is it not? Draw a normal for this surface. Then how does the light ray bend? The light ray will bend towards the normal. The light ray will bend towards the normal, okay, because the light ray is traveling from air to glass. Now, the light ray passes through the glass medium, and again at this point, again draw the normal, okay. The light ray will bend away from the normal because it is traveling from denser to rarer medium. So even in case of concave lens also, the light ray first it enters from air to glass, then from rarer to denser medium it bends towards the normal, and again from glass to air it bends away from the normal. So here you can observe that the emergent ray or this ray is getting diverged. If you take another ray like here, then also it bends like this, okay, and this will be the ray which comes out in the air. Now you can observe that this ray is getting diverged. Here the ray is moving towards the principal axis, emergent ray, here the emergent ray is moving away from the principal axis of the lens. So this is exact refraction that is taking place when a light ray passes through a lens. However, when we draw the ray diagram, we will not show the refraction which is taking place inside the lens. So what we do is, either you take a convex lens, okay, or a concave lens. We are not showing all the three rays. Here it is incident ray, refracted ray, emergent ray. Right? Here this is also incident ray, refracted ray, emergent ray. But whenever we draw the ray diagrams, what we do is we will take the incident ray up to the center of the lens. So this will be the center of the lens, and we shall just show incident ray and refracted ray only. Okay. Even for concave lens also, up to center we want to take the incident ray and just show the refracted ray. So you should remember that whenever we draw ray diagrams, the refracted ray which travels inside the glass medium is not shown, but directly we are showing the refracted ray. This is about the refraction of light when it enters a lens. So how many times the light is undergoing refraction? Light is undergoing refraction 2 times. Once from air to glass, then from glass to air. So please refer the ray diagrams that are given in the textbook also. So children, now you must be able to differentiate between a convex lens and a concave lens. As I have told in the previous session, a convex lens will be bulged at the center and it is tapering at the edges, whereas a concave lens is thin at the center and bulged at the edges. As I have told you, if you pour a drop of water on a convex lens, it will move towards the circumference of the lens because the central part of the lens is bulged for a convex lens. Whereas for a concave lens, if you pour a drop of water, it will remain at the center only. And based on the action, a convex lens has a converging action, whereas a concave lens has a diverging action. That we have learnt in previous sessions by ray diagrams. Then one more thing is, a convex lens has a real focus and by that I mean principal focus. So there the light rays, after getting refracted through the lens, all the light rays will converge at a point. They meet at a point, and that point lies on the principal axis of the lens. So that point is called the principal focus of the lens in case of convex lens. So remember, in convex lens, principal focus is a real point. Understood? Whereas in case of concave lens, the emergent ray diverges, the refracted ray diverges, and if you produce that ray backwards, then it appears to come from a point, a virtual point on the principal axis. So you should remember that for concave lens, the principal focus is virtual. So based on the shape of the lens, we can differentiate. Convex lens is bulged at the center, whereas concave lens is thin at the center. Then concave lens, it has converging action, right? And concave lens has diverging action. Then for convex lens, Principal focus, that is F is real. For concave lens, principal focus is virtual. So these are the differences between a convex lens and a concave lens. Next, before we go for studying about formation of images through lenses, so whenever you observe an object through a lens, you can obtain its image. Like we are using lenses in our everyday life. In our camera we are using lenses. In telescopes we are using lenses. Is it not? Then in microscopes we are using lenses. What we are doing? We are trying to obtain the image of the object using lenses. Now, how the images are formed, what are the characteristics of the images formed in a lens, that all has to be studied in detail. Before we go for studying about formation of images, we should remember that the light rays coming from an object, they either converge or diverge to form a real image or a virtual image. Now, if you consider an object, there will be many light rays traveling from the object and they will be incident on the lens. Inside our eyes also there are lenses, is it not? Each eye has a lens. So whenever you are looking at any object, then what happens? The light rays from the object, they enter our lens which is there in the eye, and those rays will undergo refraction and the image will be formed on the screen, that is retina, which is present in our eyes. So how it is happening in our eyes, the same way for convex and concave lens which we are designing, we can consider light rays coming from an object. Those light rays will undergo refraction and they will be producing a image. Now many number of rays will be coming from an object. So to construct ray diagrams, we need not consider all the rays which are coming from the object. So some three rays are very important to us to finish or to complete the ray diagram for formation of images in convex lens or concave lens. Now let us see which are those rays which are very important to us. Now the first ray which is important to us is a ray passing through the optic center of the lens, passing through the optic center of the lens, goes undeviated. So this is one ray which you have to remember. I shall show it by means of a ray diagram. See here. So this is the principal axis of the lens, is it not? This will be the optic center. If you consider any light ray which is incident on the optic center for a convex lens, then the light ray will go undeviated. This you have to remember. Even for a concave lens also, if you consider a light ray, okay, this is the principal axis, a light ray which is incident on the optic center, it will go undeviated even for a concave lens. Okay, so this is the first very important ray for us to construct a ray diagram. Next, second important ray is a ray parallel to principal axis. Ray parallel to principal axis. How does it behave? So for a convex lens, I shall show here. This is the optic center. This is the principal axis of the lens, right? The ray is parallel to principal axis. Now, after refraction, it must pass through principal focus only. Okay, it must pass through principal focus only for a convex lens. For a concave lens, how we have to show? Again, optic center, principal axis. See, the light ray is parallel to principal axis. Of course, a concave lens will diverge the light ray, is it not? It will diverge the light ray, but when you produce the light ray backwards, it appears to come from a point on the principal axis, that is the principal focus. So, a ray which is parallel to principal axis of a convex lens, after refraction, it should pass through the principal focus of the lens. And for a concave lens, a ray which is parallel to principal axis, after refraction, appears to come from a point on the principal axis, and that point is called the principal focus of the concave lens. So this is the second important ray you have to remember whenever you are drawing a ray diagram. Okay. Now the third ray I shall show you that. This is the third ray. A ray passing through principal focus F1 of a convex lens or appear to pass towards F1 of concave lens. Now, how we have to show for a convex lens, you see? This is the optic center, this is principal axis of the lens. So, a ray passing through F1 of convex lens. F1 of convex lens is here, right? So, the ray which is passing through F1 of the convex lens. Like that. From the object only the ray is coming. It is incident on the lens. After refraction, how it has to pass through? It has to run parallel to the principal axis of the lens. Okay. So this is the concerned ray diagram. For a concave lens, you see. For a concave lens, this is O, this is principal axis. F1 will be here. A ray moving towards the principal focus of the lens. Remember, you have to show dotted line here because the ray will stop here only, and I have to produce the light ray so that the dotted line should meet F1 here. That is first principal focus of the concave lens. So here you can just conclude that the ray is moving towards the principal focus. First principal focus of concave lens. The ray is incident here. After this one refraction, how it should run? It should run parallel to the principal axis of the lens. It should run parallel to the principal axis of the lens. Okay. So this is the third important ray which you have to remember. Okay. Please copy the ray diagrams. So, let me repeat which are the three important rays for us to construct a ray diagram. A ray passing through the optic center of the lens, it goes undeviated, and always don't forget to draw the arrowheads for these rays. Then next, a ray parallel to principal axis of a convex or concave lens. For convex lens, after refraction, it must pass through the principal focus. This will be F2 here, right? And this is also F2. A ray which is parallel to principal axis of a concave lens, it will diverge, but it appears to come from F2. Is it not? Now, a ray will pass through the F1, first principal focus of a convex lens, or appear to pass towards F1 of convex lens, concave lens. See how we have to show the ray. It is passing through F1. After refraction, it should run parallel. Now here again, this ray is moving towards F1 of concave lens. At this point, it will undergo refraction and runs parallel to principal axis of the lens. So these are the three important rays which are required to construct a ray diagram to show the formation of image either through a convex lens or a concave lens. We shall continue in the next session.